Hello everybody. So we finally finished chapter 5 and now we're moving on to chapter 6, operations on functions. So we worked a little bit with functions. In this section we're going to work even more with them and combining them, adding and subtracting. So let's read through the notes and then we'll do some examples. You add or subtract functions, add or subtract the like terms. To multiply functions, multiply each term of one function by each term of the other. To divide functions, use the first function as the numerator and the second as the denominator, and reduce if possible. A composite function is a combination of two or more functions. To simplify composite functions, do the inside-most function first. Okay, so let's look at number 1. It says, perform the indicated operation if f of x equals x squared minus 3x plus 1 and g of x equals 4x plus 5. So on number 1, it's telling us to add f and g together. So it's going to look like this. X squared minus 3x plus 1. And I'm going to put parentheses around that because that's the first function, plus the second function, 4x plus 5. So I'm just going to combine my like terms. I don't have another x squared, so it's just 1x squared. Minus 3x plus a positive 4x is 1x, and 1 plus 5 is 6. So x squared plus x plus 6 is your answer. So we're finished with number 1. Let's go on to number 2. Number 2, we're subtracting f minus g of x. Okay, so I'm writing the x first, x squared minus 3x plus 1, minus the g, 4x plus 5. Okay, so I need to distribute that negative all the way through the 4x plus 5. And I'm going to get rid of the parentheses when I do that. So I have x squared minus 3x plus 1 minus 4x minus 5. So I distributed that negative and I got rid of the parentheses. Now I can combine my like terms. You just have 1x squared, and negative 3x minus 4x is negative 7x, and 1 minus 5 is negative 4. So your answer is x squared minus 7x minus 4. And we're done with number 2. Moving on to number 3. Okay, on number 3, we're multiplying. We have this little dot, and so we're going to multiply f and g together. So this is where I'm going to use that FOIL-like multiplication. I'm just going to be very methodical and careful and try to avoid any mistakes. Okay, x squared times 4x is 4x to the third. X squared times 5 is plus 5x squared, and I'm done with that first term. Negative 3x times 4x is negative 12x squared. Negative 3x times 5 is negative 15x, and I'm done with that second term. 1 times 4x is plus 4x. 1 times 5 is plus 5, and I'm done with that last term. So now I can add my like terms together. 4x to the third. There's not another x to the third, so it's just 4x to the third. Plus 5x squared minus 12x squared. That's going to be negative 7x squared. Negative 15x plus 4x is negative 11x. And then plus 5. And that is your answer for number 3. Okay, so let's look at number 4. Number 4, we're dividing. F divided by g. Okay, so that means I'm going to write my f function in the numerator because it's written first, so it goes in the numerator. And I'm going to write my g function in the denominator. Okay, the thing is now I want to reduce if I can. So if I can factor anything in the numerator or anything in the denominator, I want to do that. But there's really not anything that I can do to factor or to simplify. So that just stays your answer. It's just x squared minus 3x plus 1. One thing you could do, if you are stuck with trying to factor, you're not really sure how to factor, you could try to divide the denominator into the numerator using long division or synthetic division. And if it divides evenly, then it's going to factor. Otherwise, it's not. So this one, it's the numerator's prime, the denominator's prime. There's nothing you can do to reduce. The 4x plus 5 has to stay all together. The x squared minus 3x plus 1 has to stay all together. So that's pretty much you're done. The only thing that is different about this one than the other ones that we have worked with so far is that in the numerator, if you remember from all your years of math, you cannot have a 0 in the denominator. If a 0 is in the denominator and you try to divide by 0, like in your calculator, you can type it in, 1 divided by 0, and you get an error. It doesn't work. You cannot do that. So, whatever this x is, I cannot let it be a value that is going to make the denominator equal to 0, because that's not going to work. So, you have to solve for x, decide what the value is that's going to make that 0, and part of your answer is to specify that x cannot equal that value. So what you do is you're going to take the denominator, set it equal to 0, and solve for x. So I'm going to subtract the 5, divide by 4, and for the denominator to equal 0, because I set it equal to 0, so for the denominator to equal 0, x would have to be a negative 5/4. You can plug that in for x and you will get a 0. So I have to specify as part of my answer that x cannot equal negative 5/4. So all of this is part of your answer. Anytime you get a fraction that has a variable in the denominator, you have to specify what it cannot be. Okay, so let's move on to the next part. I'll tell you what, this is a good place to stop. Why don't we stop here and you can take a break, go get a drink of water, whatever, and come back for part B. See you in a minute.